Welcome back. Now let us see how we can solve part B using method 2. So method 2, this is the method of perpendicular lines. So part B, which is x squared plus y squared minus 4x plus 2y equals to 3, and the point of tangency, this is the point on the circumference of the circle where the tangent meets the curve. This is what we are calling the point of tangency. Point of tangency. Now, for us to apply the concept of perpendicular lines, it is very important to sketch the circle so that we are guided and we can easily visualize. So I'm going to sketch my circle in this manner, and I assume that my tangent is touching the circle at this point. That means this point becomes the point of tangency with coordinate 0 and negative 3. Then we call the point of tangency maybe point A, and the point from where the tangent is drawn to the circle is maybe just call it point B. Even if you leave them, there is no problem. Now we know that at the center here we have the coordinates of the center, and when we join the center to any point on the circumference, now say the point of tangency, it makes an angle of 90 degrees with the tangent. That is tangent. That is, the tangent is perpendicular to the radius and vice versa. Now, what are the coordinates of the center of this circle? The coordinates of the center, you can get them from this equation, which is in the expanded form. So, if you have practiced, then you have clearly seen that the coordinates of the center are 2 and negative 1. Now, after getting the coordinates of the center, this is what we do for us to apply the property or the concept of perpendicular lines. What you do is, since we have the endpoints of the diameter, so we have the endpoints of the radius because this is our radius, not the diameter. If we have the endpoints of the radius, and we know that a radius is a line, that means we have 2 points on the line, or 2 points as the endpoints of the line, which is the radius. Then we can get the gradient of the radius. So let's get the gradient of the radius. Gradient of radius. And clearly, radius is a line. That means it is a line joining point C to point A. So point C is 2 and negative 1, and point A is 0 and negative 3. This is the point of the center. This is the point of tangency. We can use those 2 points to get the gradient of the radius. Then we'll see how it will assist us to find the equation. So gradient is given by n as changing y out of changing x. Therefore, you come and then you point this is my x1, y1, x2, y2, or vice versa. So we substitute here. What is y2? Negative 3 minus y1, negative 1, out of x2, 0, minus x1, 2. This here gives us pressure calculator so that your signs are operated in the correct way. Negative 3 minus negative 1, negative 2 over 0 minus 2, negative 2. If we divide, we shall get 1. Negative 2 divided by negative 2 gives us 1. All markers. So this one that we have got here is the gradient of the radius. Now, how do we relate the gradient of the radius to the tangent? We have said that the radius is perpendicular to the tangent. That means they meet at a right angle 90 degrees. So the concept of perpendicular lines says that if two lines are perpendicular, then the product of their gradients is -1. So when we say but the radius is perpendicular to the tangent. What does it mean? This implies that the product of their gradients is -1. So we know that the product of the gradient of the first line and the gradient of the second line is -1. That is the concept that we know under perpendicular lines. If two lines are perpendicular, then the product of their gradients is -1. That means, let me call this one the first line. So M1 is the gradient of the first line, which is the radius. In that case, this is my M1. And now my M2 is going to be the gradient of the tangent. So let us substitute now for the gradient of the radius, which is M1. Therefore, if I put here M1 and have 1, M2 equals to -1. If I make M2 the subject, therefore my M2 becomes -1. This is now the gradient of the tangent, which is the second line M2. This one now is the gradient of the tangent. Therefore, the gradient of the tangent equals to -1. Now, after getting the gradient of the tangent, this is the tangent, and you know one point on the tangent, point A. Point A is the point of tangency being shared by both the radius and the tangent. So we can find the equation now of the tangent since we know the gradient of the tangent and one point on the tangent. Why? Because we know point A as 0, -3, and then we know the gradient of the tangent M2 as -1. Now here we can use the equation of the line to find the gradient, to find the equation of the tangent, which is y equals to mx plus c. This is my x, this is my y. That means substituting here, and then this is my m. I have -3 equals to m. M is -1 times x, which is 0, plus c. Therefore, here my c gives me -3, where I will know that c is the y-intercept. That is the point on the y-axis when the line, which is the tangent in this case, meets the y-axis. After getting c, then in the equation we just substitute for m and c, because the equation of the line defines generally the line at any point. So therefore here we shall have y equals to, where is our m? -1, but there is x there, plus c. C is -3. -1x is the same as -x, therefore y becomes -x minus 3. And now this is our equation of the tangent to this circle at the point of tangency 0, -3. This is the solution to example 3.